Hello, everyone. Good morning, good afternoon, good evening, good day, depending on where you are from around the world. And if you're on demand, welcome. My name is Josh Epstein. I am the Chief Marketing Officer at Aras. It's my pleasure to be moderating this panel discussion and this series of panel discussions that we've been doing over the past few months. We call it the series Pulling the Digital Thread. So the idea is that we explore trending topics and technologies that are shaping digital engineering, digital manufacturing, product lifecycle management, and the broader digital enterprise, all from the perspective of this connected data and information that we call the digital thread. So our goal is to bring together independent thinkers to exchange ideas, their opinions, have some fun while we're at it. We're streaming on a short delay today so we can get some good high quality audio. So while we won't be taking questions live, we do encourage everyone to participate online. So on LinkedIn, if you just want to use the hashtag pulling the digital thread, we'd be glad to follow along the post. Glad to hear your thoughts and ideas. Feel free to ask questions, and the panelists will answer in kind. So this discussion is being recorded and be available on demand after the event. And so with that, let's dig in. So today we're exploring, really revisiting this topic of how AI is transforming PLM and digital engineering, and particularly looking at what's changed over the last 12 months, which, as we'll get into, a lot has changed. So I'm pleased to be joined by four leading thinkers in this space. Welcome to Guy Bursell from Microsoft, Rick Razor from AI Marketplace, Jonathan Scott from Razorleaf, and Rob McElvaney from Aras. So to start, we'll just do a quick round robin, and I'd ask each panelist to do maybe a broader introduction of yourself, of your organization, of your interest in this space, and maybe as an icebreaker, name your favorite dystopian AI apocalypse movie. I'm going to go personally with The Matrix, so no one else can kind of copy that. Everyone has to have a different one. With that, Rob, maybe kick off and tell us about yourself.
Sure. Thanks, Josh. I'm Rob McElvaney, Chief Technology Officer here at Aras, where I've been here for more than 20 years, trying to figure out and push the state of the art forward on digital thread solutions to be able to connect engineering, manufacturing, quality, service, maintenance, bring them all together into a full end-to-end product lifecycle connected through this digital thread. Excited to where this technology is going, especially in the area of AI, as we'll be discussing today. I guess my favorite dystopian AI future movie would probably be The Terminator.
Good one. Rick, how about you?
Yeah, thanks for having me. My name is Rick. I was researcher at Fraunhofer Institute in Germany for a while. I had various positions there. I was building up the digital engineering group with the focus topics of product lifecycle management, MBSE, and AI in engineering. And currently, I'm a co-CEO of a startup called AI Marketplace. And yeah, we are helping companies to search, find, and operate industry-ready AI solutions in engineering. And you took my pick. The movie I was thinking of was also The Matrix, but maybe then I took the second one, Reloaded.
Fair enough. Awesome. Jonathan.
Yeah, likewise. Thanks for having me. My name's Jonathan Scott. I'm with Razorleaf Corporation. So personally, my background is in mechanical engineering. That's how I got into this space of software and IT 20-some years ago. But these days, I'm chief architect at Razorleaf. I spend a lot of time talking to customers about how to apply technologies, whether it's PLM or AI or other things, to their business problems, how to solve problems using tech, and how processes and data and people all fit into that. So that's really what Razorleaf does. We're a consultancy around digital product information, whether it's in engineering, manufacturing, or other areas. I'm based in Norfolk, Virginia. And let's see, my favorite dystopian AI movie. So I think I'm going to go with Ex Machina. I don't know if anybody
That was a
knows
good
that
one.
one, but
That
I
was a
thought
good
that
one.
one was fantastic and a great warning and thought piece for all of us.
For sure. For sure. All right, Guy.
Good morning, Josh. Pleasure to be with you today. Now, I lead the solution strategy in Microsoft for the manufacturing and mobility industry team, specifically around the area of design and engineering on the cloud. So I get to work with a lot of customers, partners, our internal teams, and really empowering our customers looking to move and accelerate digital engineering on the cloud. I've spent over 20 years in the PLM space. I was a solution architect and then later a product manager, and I joined the manufacturing mobility industry team here at Microsoft about 4 years ago. And I'm based in Redmond, Washington. So my favorite dystopian AI apocalypse movie, I mean, for me, it's not so much an apocalypse, but it has to be Stanley Kubrick's 1968 classic of 2001: A Space Odyssey. And the first 3 words I open with, and as the HAL 9000 would say, "Good morning, Josh."
I like it. I can't help it. Sort of, that was a Daisy. Singing the song Daisy as a how goes off the rails. Awesome. Well, let's dig into this content. So to start out, Rick, you actually were here just about a year ago, where we talked about kind of the work you were doing at Fraunhofer and AI marketplace, and really thinking about the how generative AI was really transforming different elements of PLM. So with that, I'd like to just maybe share the presentation that you used then. I'll bring it up right here. So this was last year, and you kind of went through this cool little heat map of looking at common business processes across PLM and rating them as which ones were nearer term, high potential, which ones were maybe further off. And then you recently shared this version where a lot has happened in just a year. So I'll kind of do this side-by-side piece, but you want to talk us through this and kind of give us a sense for, in your opinion, what's changed?
Yeah, sure. I think in the context of AI, a year feels very, very long. So maybe we have to update it within months, not within a year. So I think the main difference is that a year ago, the primary focus of the whole field of generative AI was very strong of processing the text-based artifacts within PLM. So everything around the more or less obvious stuff like requirements or technical documentations has got a high potential, right? Because LLMs was strongly focusing on text-heavy stuff, right? So, and within the last year, I think we see a big shift or expansion, more or less, to these so-called multimodal models, right? So I think most of us are aware of the image models. A few of us are aware of what's happening in the video field, right? And I'm pretty sure, and this is also the change that we see over the last year, that the generative aspect is more or less empowering other fields, like we see on the right side. So it opens us more or less a broader application of Gen AI to other artifacts like systems architecture. So this is one stream. The other stream is obviously within a year, the model quality has gone wild, right? So we've seen new models almost every week and improvements from different players. And this leads us to the stuff that I already mentioned, that we are now, for example, capable of creating system architectures, right? So talking about that is more or less a formal representation using a graphical modeling language, and for the user it's like a diagram or something like that. So it's not text based, right? But now AI models are capable of generating that as well. And I think this is also quite interesting if we look into the fields of more or less classical master data management stuff like variant management, bill of material management. We see that all the LLM stuff has gone in a broader way around the stuff where we really need precise answers, right? A year ago, you used it for stuff where hallucination and maybe not the perfect or very precise answer was not so crucial, right? Thinking about website texts or maybe social media posts, right? Where a little bit hallucination maybe can also be something that is good. But nobody had thought of the stuff that we can really use it to process a huge amount of master data. For example, if we have structured lists or bill of materials, right? And now this is possible because the context window is getting bigger and bigger. We have different approaches how we can, at the end of the day, manage the hallucination and try to keep the error as less as possible.
That's great. Maybe, could you maybe double click a little bit into that piece of some of the approaches to manage basic hallucinations? Any kind of, I don't know, frameworks or paradigms you think for different use cases that are worth talking about?
I think it's like always, there's not one fits all solution, right? But we've seen huge happenings around the approaches that maybe also Guy can add a little bit around that we call RAG. For example, that we use data from the company to actually enhance an LLM with the stuff that came from companies' data or company databases, right? In addition to that, I think a very big part is that very, very big research is done in the field of how we interact with the LLM, right? So it always started with a zero-shot prompting, right? So how we interact with the typical user-orientated systems like ChatGPT, but there is a lot of stuff, maybe a chain of thought or tree of thought approach that we can use to enhance the quality of the output. And also, and this is maybe not only a technical aspect, is that also the cost of the inference is getting lower and lower. So we are mostly able to do big test sets or doing maybe the question 2 or 3 or 10 times to get at the end of the day a way that we're really sure that the processed output is or has a lower error than maybe a year ago.
I'm curious the other panelists thoughts on some of these other areas that generative AI is starting to bleed into. Any experience with any of these?
Yeah, there's I think there's been a rapid expansion over the last year. One of the key drivers, I would say, is the fact that manufacturers especially are able to securely use methodologies like RAG, as Rick mentioned, to train these models on their own data, and I think that's really crucial. Having the ability to really hone these models in on a company and an industry specific subset of data.
Now, I'm curious, Rob, in the area of product engineering, and I can still envision how an LLM, does really well with doing some clever things with massive text-based documentation. But how have you seen thinking of how to apply generative AI in particular to more structured data to really start aiding in things like product engineering or requirements engineering? Kind of what's your perspective on how this is happening in the real world?
Yeah, it's obviously fast moving, but what I'm seeing at least is much more focus on feeding AI with structured data in a way that can result in better outputs and fewer hallucinations, as Rick alluded to. This is really been, I think it's been happening quite quickly. Where last year we were really talking about LLMs being able to read, understand, and respond to really text-based and prose kinds of formats. Now we're seeing that it's able to ingest learn from, train upon, and then output data that is in formats that are much more useful for the kinds of business systems that we're talking about here. So the jump, or the step, has been, yes, it's great that AI can read a long document and summarize it for me. It's better if AI can read a bunch of structured data and be able to tell us what's wrong with it, what's missing from it, what insights can be drawn from that data.
I want to come back to that piece and some questions for Guy, but I'm curious. Rob, you've been on a speaking tour lately, and I caught one of your talks in Paris, or in Germany, about leveraging AI, particularly around requirements planning, to really extract and transcribe and really synthesize massive amounts of unstructured data, but really actually pull out and kind of parameterize engineering requirements, whether it be standards, compliance implications, or what have you. Can you expand on this and really help us understand how AI or can be used to actually improve the digital thread of an organization?
Yeah. Absolutely, and we've seen several ways where this technology can be applied, and we're working with several partners on building these capabilities out. But I think that the easiest one, or the first one that we would explain, is requirements have come from many sources. Often requirements are coming from a document that is provided by a customer, or maybe provided by a regulatory body or an international standard. There's all sorts of documents that contain requirements that we need to reference in our daily life. So in order to release a product into a locality or a country, we have to know the regulations of that country. We have to know all the space within which we need to operate. And so the ability to take those long documents, to break them down into individual requirements instead of long blocks of text, break those down into individual requirements, and then provide traceability between the internal requirement that says must comply with ISO standard X, to breaking down ISO standard X that was delivered as a PDF file somehow. We're breaking that down into the individual requirements, and then providing traceability for why a internally developed requirement, the chain of, or the digital thread of how that was derived from the international standard. That's a pretty interesting use case in the work we're doing, because right now we don't have a sufficient level of traceability. We just know that somebody wrote a requirement because ISO said so, right? Not because paragraph 3.7.2.1 of this standard said so, and here's our interpretation of it, and why we have to do that. If we go a little bit further along from there, now it is, okay, I have requirements from many different sources that have been synthesized and kind of brought together into a singular store. Now we can do things like compare requirements to see if there are any conflicting requirements, to see if there are duplicate requirements, and be able to do a level of analysis to determine what the right set of requirements to use as input to a product development process. And then, I guess, lastly, the third thing I'll say is that requirements come from all over the product lifecycle. It isn't just requirements going into the design of a product. It's requirements for how I manufacture it, how I maintain it, how I measure carbon footprint over its lifespan. All these things are coming together, and so the AI can be used to structure the requirements in a way that they can be connected across the lifecycle and identify the linkages between these different types of requirements for different phases. So really, lots of opportunity here in the requirements management world.
Yeah, let's
Josh,
open up and please, Jonathan.
I just wanted to jump in on that because I think, Rob makes a really important point that we focus on with customers a lot of the time, and that is to try and break down your problems and your challenges into bite-sized chunks, right? And we can sometimes convolute this idea of AI with, it has to be this thing that solves everything, and then we get worried about hallucinations and is it answering right? But the use cases Rob just talked about, right, they match perfectly with the business problems a lot of customers are trying to solve today. I've got requirements as documents, but I want them as data. Once I have them as data, I want to rationalize them, right? But when you think about it in those building blocks, you can start to see the technology application more clearly and be less worried about some of these things that slow us up and, kind of get in our head about, it's not a fit. So I really like the point that Rob's making there.
How well equipped do you think the modern AI savvy organization is, right? A not so savvy organization is to actually put this into practice? And do you think this is an opening for new service providers? I mean, is Razorleaf interested in kind of helping coach an AI or kind of curate an AI through this process? Or how's this going to happen? I mean, there's not ChatGPT is not just going to crawl in our data. We're not going to let it crawl in our data and do this automatically. How do companies organize around getting this done?
It's a great question, Josh. I think that you have to get past the hype. That's really the key. Is this is a new technology. Okay. Having said that, it's exciting. I mean, it's amazing stuff, right? But by the same token, it is a new technology. You have to think about where it fits, where it doesn't fit, the risks, how you apply it, what are the costs, all those things. And that's how I think we'll see this evolve practically and pragmatically. I mean, there will be folks who swing for the fences, and I'm glad that they're there, and that's going to lead us to exciting use cases we haven't thought of. But I think it will be a combination of people who are AI and tech experts who say, where can I apply it? And also people who are experts in certain domains who say, wait a minute, AI is a new tool. How do I use it for doing the things that I'm trying to help my clients with today? So I think it's going to be a blend. But the thing that will help us all is when we try and see past the hype into the use cases like Rob was talking about. That's my take anyway.
Yeah, if I can just build on that. So the scenario that Rob and Jonathan are highlighting here around requirements engineering, when we think about product development and we think about product complexity, there's multiple dimensions when we're thinking about requirements. There's product requirements. There's regulatory requirements around products, multiple levels. But with product complexity, embedded software plays an outsized role in new products that are coming to market. So it's not just about thinking of product requirements and that traceability, but it's all the way into how are we bringing in software development as part of the overall product development process. And that piece of how we're kind of bringing these two together, product requirements, software requirements into product development, it is probably one of the largest impact areas for generative AI that we're certainly seeing at the moment.
Yeah, I think that's absolutely, and even in thinking about the power of generative AI to support coding and developer productivity in particular. So, Guy, maybe just sort of double clicking on that. So, Microsoft, one of the most powerful drivers in adoption of enterprise AI. We're all familiar with the power of Microsoft-powered copilots. Obviously, many applications for Copilot smart assistants within the PLM context to both kind of give users, help users navigate the massive amounts of data information managed by a PLM system. But I'm curious, what are you seeing as the more novel or the most novel applications of AI or generative AI in engineering? I'm curious kind of what you're seeing as really the cutting edge, bleeding edge type applications.
Mm-hmm. Yeah, it's the last year, I think, have really seen just some absolutely incredible innovations. The progress and evolution of different AI technologies really means that we've got a range of capabilities that allows us to introduce new interfaces across applications that are, as Rick said earlier, multimodal. So we can support, text, image, speech, videos. We're now in the realms of 3D CAD models. I mean, it's absolutely phenomenal, the speed at which, at which this is moving. So we've got, a new experience that retains memory and context with the ability to reason and complete, these highly complex cognitive tasks, aiding the engineer, us humans. And I think we're certainly seeing a new, what I would term as a agentic world that's emerging. You've got such a rich tapestry of different AI agents. You've got personal agents or copilots. You've got business process copilots. You've got regulatory copilots and cross-organizational copilots. And, and the engineers are using all of these. And we've got these large language models that are, being trained over these huge volumes of data that previously were maybe not that accessible. These are all overlaid across digital systems and critically the infrastructure. And I honestly think it's one of the most exciting shifts of our generation. And I'm an engineer at heart, and we're seeing this impact take shape for every individual, every business process, every organization, and literally every industry. So I'll pick a bunch of examples, and you might have to cut me off at some point because I mean, just what's happened, I think, over the last year, there's so much to cover. So I think in manufacturing, I'll certainly start with engineers being able to use Copilot assistants to interact very efficiently, being able to summarize, extract, consume recommendations or large volumes of data that can be very concisely kind of segmented, which is really you think about very complex and time-consuming impact analysis for engineering change as an example. I mean, this is a regular conversation I have with many customers. Or just being able to get down to that product data that you're looking for very, very quickly. So copilots or AI assistants, are very well suited as these large language models can be securely trained on the company's private and industry-specific data. And some methods like RAG are actually, they're just, a great enabler for this because the data never leaves the customer's tenant. You take this a stage further, and this is actually a reality today. Imagine, a field service engineer taking a photograph on their phone, submitting that image to PLM, where they're using AI then to identify the component parts of the product, and then return the product, identify and return the product data in the search very, very quickly. AI is being used in very contextually complex application UIs to kind of help guide users and around their selection. You think about moving that into automating workflow processes and then reducing that cognitive load. But the engineer, we as humans, are still there to kind of guide that process to really verify that the results are correct at the end of that. I think in CAD, generative AI especially, it's been used to drive some very complex modeling and design scenarios. So generating 3D models and think about accelerating or automating assemblies. I saw an amazing example actually earlier on this year. Get a Copilot interface where you can go and describe the type of electrical connector you're looking for, and include characteristics like the ampere rating, the voltage, etc. And then the Copilot then with generative AI will automatically generate the 3D CAD model. There's a simulation. There's all the accompanying table metadata that gets generated. And then the AI model was trained on the entire product catalog. And if there isn't a connector that meets the need, then it will create an optimal design for the connector and adds it to the catalog. So that catalog and all of that data, where's it going to be stored? It's going to be in your PLM repositories. There's a similar story in other engineering applications, like EDA is another great one. Really using generative AI to lower the ceiling of skill sets that are required to, for engineers to use these types of really complex applications. And making engineers much more productive, making them much more efficient, and lowering the investments that companies need to make in, investing in training, for example. So it's not only helping them address the skills gap, which if you think, I think in the US alone, there's we're around 3 million is the STEM skills gap. If you think, across industry. And, one of the most, I think, exciting areas I'd see for AI all up in engineering is simulation. And what's becoming a convergence, or really a confluence, if you like, of machine learning, deep learning, AI physics, and generative AI all coming together to massively accelerate simulations with maintaining a very high degree of 98% plus accuracy. And that's simulation driven by inputs, which is a lot of data, generating even more volumes of data as outputs from those simulations. We've got copilots, to help guide users for self-help and support within applications. That's a very common pattern. We talked about requirements engineering earlier, which is, I think, a super impactful area. And, overall, the net result that you're seeing is higher product quality, more right first time. You've got that consistency. You've got efficiency, you've got productivity improvements, but ultimately you're getting faster time to market.
Yeah.
And I think the last point I'll make is I think the future in engineering looks just amazing. We're seeing companies thinking, what's next? That next horizon, if you like. And this is where, if they're thinking about a digital engineering copilot, and this is where I like to think of a Lord of the Rings analogy of one copilot to rule them all. You've got this broader kind of umbrella, if you like, of a broader engineering copilot trained on your products. Okay, and essentially it's orchestration.
Yeah.
Okay. You've got application automation. You've got AI being leveraged in all of the different applications. Let's face it, engineers use a lot of different applications.
Yeah.
And it's really that kind of pathway into really being able to scale to a true really true kind of business accelerator.
Yeah, I am going to cut you off because that's like a lot to chew on here, and I have a bunch of questions. I want to kind of go back probably in reverse order, but certainly I think that your last point on the ability to kind of work across a massive set of business processes, applications. That's why we think a digital thread is so fundamental to actually operationalizing AI. But I'm going to go back in reverse order, I think, on some of the things. So simulation, and I'd love. Jonathan, Rick, Rob, your perspective here. I know, Rick, you're an expert or a veteran of MBSE and kind of thinking about systems engineering. And we spoke recently about how AI is impacting, the world of system engineering. We've also had some talks with folks from ANSYS and McKinsey on the kind of modern, advanced simulation and AI kind of convergence. But I'm curious, what's your perspective on how this is working together and what the potential is?
I think the overall point is that we will see these agents all all over the engineering IT world, right? So I think that the examples you mentioned are very fascinating, and I'm super interested how the UI will look in the future, because I'm pretty sure the agent or the copilot will take a very unique role in this IT systems, right? I think it's not the same like we're thinking, for example, for a service agent or website agent, right? Because in engineering, and you mentioned all the examples, we are often rely on very complex representations, right? We are using BOM list, we are using wiring diagrams because it's not too easy to explain a wiring within natural language, right? And the same is for simulation, right? I think the visualization of what the simulation result is at the end of the day something that that's crucial and can be empowered by these kind of co-pilots, right? And I love the image of the original co-pilot in an airplane, right? So it's something that really empowers the users in front of the application, right? So if you imagine of the airplane, somebody really takes control of the flight and the other one is looking at the system, at the instruments, right? And I'm pretty sure that we will see this kind also in the engineering IT, right? Maybe coming back to requirements engineering, somebody will create a requirement, and the co-pilot will look for the data quality. He will ask, is there a test case that you can assign to, right? So this is stuff that that will really be fascinating to see how the UI is implemented in simulation, in PLM, and so on and so on.
Yeah, the back on the topic of agentic AI, and really of kind of thinking about how AI agents can plug into different elements in the PLM process. We'll just sort of focus there for a moment, and really beyond just descriptive kind of synthesis, really start getting into prescriptive recommendations or checking of work or automating workflows. Rob, Jonathan, I'm curious your perspective on that, the potential here and kind of likely near term applications of this type of work.
Yeah, my thought is that agentic AI is going to be sitting in the background, doing the multidisciplinary optimization that engineers today have to do by cobbling together 7 different simulations in series and getting to an answer. We are going to see, I think, pretty quickly. We're going to see those multidisciplinary optimizations happen. We're going to see things like deep learning surrogates take the place of very, a quick chatbot, right? What if I change this parameter? What are the expected effects? Those kinds of things are going to be coming very quickly, and then over time, we'll see in the background that agentic AI is going to be running these simulations, doing the optimization, and delivering a proposal or a suggestion to an engineer who can then verify it with the tools they have at hand. And really, this is to me, it's not in the short term. Sure, we're going to be talking about optimizing our processes and optimizing within the optimizing our existing products. Right. I think as we move forward, we're going to be talking about AI really assisting in the innovation that's going to create better products than we have today.
Yeah, I'll jump in there and say I love this idea of the agent because I think it addresses one of the big obstacles we're going to see in adoption of this tech. Because I mean, it's so exciting. Everybody's excited about it. Like I mentioned the hype earlier, but a lot of people are going to be scared of it, and a lot of engineers are conservative. And I think the notion that it's an agent, it's a helper, really is going to drive adoption of some of this, right? So I think of it like spell check for engineering. I mean, Rick was kind of alluding to that, talking about requirements. All right, did I write a good requirement? Is it already a requirement? Did I duplicate one? Like, these are simple, basic checks that these agents can be doing for us that are going to save time and save energy, that are not threatening and not big risks, right? So people can get comfortable with it just like they've gotten comfortable with spell check. I remember 20 some years ago, early in my career going, spell check, I don't need that. It'll make me forget how to spell. Okay. It's on all the time now. I love the red underline. It helps me, that kind of thing. And we see it incrementally getting better. Oh, it's guessing my next word. Oh, I hadn't thought of phrasing it that way. Is this going to do the same thing for us, right? And I hope so. And I hope it's going to be in practical terms that people see that real value, like impact analysis. All right, I did my impact analysis. I looked around in PLM for what's connected, this, that, and the other thing. And then AI said, yeah, but what about this, right? It was like the senior engineer over my shoulder going, yeah, but you might have forgotten, but just check it. I'm not saying that's what it is, but just check it, right? And so I think this agent concept is really important because we have to think about adoption, not just capability. And people aren't going to be comfortable unless they kind of see that as, it's helping me out. I see how it's going to work.
No, that's great. Maybe Jonathan, we can stick with you here. I think you as the you and your team are working day in, day out in these figurative trenches of deploying a PLM. So as you're working with engineering and IT leaders, and as they're thinking about applications of AI, what do you see as the main impediments for not moving faster in the reality?
It's a great question, Josh, and I think there are more answers to it than I'm going to offer, right? But these are the big ones I see, and they're probably not going to be surprising to anyone. The first is a reluctance to trust AI, right? People are excited and scared by it all at the same time, right? Just by the question you asked us at the beginning for the icebreaker, right? AI movies that are science fiction, we love to think about it, but we worry about the apocalypse. So I think that there are a lot of engineers who are conservative, who are not eager to trust something that they don't fully understand, or in some cases that doesn't completely show its work, so to speak. Mm-hmm. So I think there's going to be a reluctance there, but the silver lining on that one is it reminds me a lot of cloud computing 10 years ago in the engineering space, right? There were lots of engineers that I spoke with 10 and 12 years ago. No way will I ever put my company's intellectual property on the cloud. There are a lot of people today doing it, and it's working. And we just sort of followed this technology adoption wave. So I think we're going to see the same thing related to trust in AI, but that's one. I think another one that's a big obstacle for people and is slowing them down is something that Guy mentioned earlier, right? And that's IP protection, right? And so I want to come back to something Guy mentioned because I don't know that we explained it here, and maybe the audience knows it already, but RAG framework, right? So retrieval augmented generation, and the idea that you could have an AI that has large language models, understands things, et cetera, but when it gives you results, maybe it's not going from that data set to give you the results. Instead, it's retrieving your data, your secured data, and then looking at that to give you your answer, right? So these models of how can we leverage really, really smart models, but with limited or secured data sets. And that's just one concept. But that point about, hey, how is my intellectual property being secured is something people are going to need to think about and understand before they get comfortable with it. I'll give you another practical example in that area. Lots of PLM systems, right, because they're great collaboration tools, will house a company's IP, but sometimes will also house their partner's IP, their customer's IP. And they segment it and they secure it, et cetera. But when we go to apply AI, just like when we've been applying search to date, you have to think about how all that fits together before you start just opening the floodgates and saying, oh, this information is great, get out whatever you want. Mm. So I think IP protection is another one. And the third one I'll mention is, frankly, it's the state that people are in today. And this is tough, but this is where people are at, is not having the control and connection of digital data, digital product data that people need to leverage some of this, right? So the tech's great. The tech is it's getting there and it's ready and it's ready for some of these use cases. But if you're still not managing your CAD data and connecting it to your bill of material data, if you're not managing your requirements and you can't collect them all in one place, it's going to be very hard to use that as a data set for getting answers, right? So that's a place where a lot of companies can improve their adoption of AI in the future, but even improve their business processes today, right? So I realize I'm kind of giving a self.
No, I think it's perfect. I mean, I'm curious in the other folks' response or elaboration or other impediments that we're seeing.
Maybe I can add a fourth one, but add a comment to the last one. I think that's something that that Rob already mentioned. If you're not on the, let's say, readiness or state that you can really leverage your whole data with AI, then you can use AI to do that, right? You can use it to pass PDF documents into data, right, and then self-empower the system to build a reg not based on the PDF rather than on the structured data, right? So there's something that you can already try to solve or try to address with AI as well. And I think there's one further challenge, in addition to, let's say, the IP protection and security, which is, I think, obviously addressed by, for example, Microsoft, right? So as mentioned, you can put all your data in your own tenant, right? The challenge we often see, especially building solutions, is that we have a really fast pace of Gen AI technologies right now, right? So a year ago, somebody would try to approach a project, let's say, with fine-tuning a model, for example, and then, let's say, 3 months later, you can do it with a better quality, less cost with RAG and a standard out-of-the-box model, right? So, and if you're now building a solution, nobody tells you that with the next model, all the effort you put in it could be done out of the box by GPTX, right? And for this reason, I think it's really crucial to find the right use cases, right, where you have a quick return on investment and as well, let's say, a long-term value of the use case, right? Because then you're not heavily depending on the technology's back-end approaches.
That's
completely agree with that. And I guess as a corollary to that, have a data governance strategy that is aligned with your current and potential future use of the technology. You can't expect to narrow down the data you're going to use with today's LLM versus tomorrow's model. You need to have a strategy that spans as the technology is moving so quickly.
Yeah, I think 2 points I'd make. There's obviously a lot of concern, as Jonathan mentioned, about, how do engineers trust AI? I have this conversation with manufacturing customers all the time. And we approach this, essentially in 3 pillars. I mean, over a year ago, we started our Secure Future initiative. It was actually a year ago now. Since then, it's really been expanded, and it's a company-wide commitment and responsibility that we feel to make our customers more secure. I think there's something like 34,000 engineers working on this initiative. The second pillar, privacy. Data is the absolute foundation of AI. And our priority is to help ensure customer data is protected and compliant through our longstanding privacy principles, which includes user controls, transparency, legal, regulatory protections. So what that really means is, we give you the ability to control your data along with the choices on how your data is used. It's protected through some very rigorous means. We design our products with privacy in mind, focused on upholding, users' privacy, and we stand up for rights, for making stronger privacy laws and protections. But the third pillar, I think, is really around, for trustworthy AI, is around safety, both security and privacy. We have our broader responsible AI principles, which were established, I think, back in 2018, 2019, so way ahead of any kind of regulation, in this space. And it's a framework that helps us to ensure that we're building, testing, deploying, monitoring AI with our around kind of 6 kind of key principles. And really to avoid any kind of undesirable behaviors, such as, you think about harmful content, bias, misuse, other intended kind of risks. Any kind of fine tuning stays in the Azure subscription. So there's a lot there to help support thinking about, how do we trust AI? And we build that, front forward into our thinking. The second piece, and I think we've seen a lot over the last year around large language models. Okay, the next iteration, or then the next kind of horizon is already here, and so I think you're going to be seeing and hearing a lot more, especially in engineering, around the use of small language models. So maybe that's an area that we could come back to explore in the future.
Yeah, no, for sure. I think it's probably a good spot for us to pause. I think what we should plan on is a year from now, let's come back and let's have the same conversation. I think I'd like to think we have a year before Singularity or the return of Arnold Schwarzenegger, but it's hard to say. Things are moving very quickly, but this has been a great conversation. I've enjoyed it. I know that our listeners have enjoyed it. Thanks all for being part of this, and we definitely will have you back in a year, if not sooner. So thanks very much for participating.
What you're saying, Josh, is in a year, I'll be back.
Oh.
Nice work, guy.
Nice work, guy. Thanks, everyone. Appreciate the time.
All right, thank you.
Thank you.